Alright guys, so welcome to the session and I hope all of you guys are doing good. So let's get started with today's discussion. Before we proceed further and before I start this session, I just wanted to highlight some of the things. First of all, those guys who are not having understanding of Python, they will not understand these sessions from the next class because now we are going to build the entire agents, right? So this course is basically designed for those guys who have the basic understanding of Python. So those guys, I see some of the learners coming from DS14 as well, who are new to the field of data. So for you guys, this may not be the session, but as you joined, so you can very well be part of it. But once you have the understanding of Python, then you will understand this later on. So as you are not aware of that, so if you want, you can leave as well. Okay. But if you want to be part of it, that's okay. That's fine. But just to highlight that Python is required here. And second thing is that this is going to be a very technical session. So we are going to build a lot of interesting agents in the entire curriculum. And these days, people are talking about agentic AI and all those stuffs. So this is going to be one of the things which you should be aware of, right? It's a state of the art skill and you should be have the understanding of the same. So for the people who are not aware of Python, you will get to know all these things later on. But as I mentioned, if you want to be part of it, that's okay. Okay. So let's get started with this discussion. I'll take all of your doubts at the end of the session, right? Today I'm planning to cover the basic understanding, which I already talked about for many of the folks, but some of the folks newly joined. So I will talk about that again. And the entire session on the agent building and all, we will be discussing in the from the next session mostly, right? So let's see in next 2 hours how many topics we will able to cover, and after that we'll plan. But the idea is that this is going to be around 40 hours of sessions, and by the end of this 40 hours, you will be having a very good understanding, and you will be start creating the agents which are needing for the industry aspect, right? So this you can very well add in your resume and you can very well showcase that you created these type of agents. So it's going to be very exhaustive curriculum. It's not that we are just talking about high overview. No, it's not like that. We are going to talk about very much in detail. Okay. All right. So let's get started now, finally. So first of all, motivation, which we have. So why to learn this, right? Why it is important to learn this? Because have you ever imagined building an AI assistant that does not just chat, but actually thinks, plans, retrieves data, makes decisions, and even executes tasks across your tools, databases, and APIs? Well, the future is already here, right? And this is what many companies are developing. And there is a huge amount of requirement gonna be there. And as early we understand these concepts, as early we start working on this, more we will be in the demand. And that is the reason for our learners, we came up with this program so that they will get hold of these things and they will start working on this and they can start putting in the resume as well. It's very important. And I will make sure that you guys will have a better understanding of all these things. Now, why agentic AI is the future of work? Traditional AI answers question, agentic AI gets work done. Companies are no longer building just chatbots. They are deploying agents that read documents, query APIs, run workflows, and even talk to each other as well. And these type of applications we are going to build in this entire curriculum, right? So it's going to be very interesting one. And you can see that a lot of things are happening automatically. We will just write something in English language, and based on that, your agent will respond and your agent will do the task. Now, how the real world is already creating agents, right? So many companies are, as I mentioned, they are working on it. They are doing a lot of things. And here are some of the examples. Uber, dev support agents, saving 21,000 hours of developer time, right? So what they built, internal line graph based AI agents that help developers answer repetitive queries like how do I onboard to a repository, what's the API documentation, and so on. So here you can see some of the new terms coming in like line graph and all. So all those things we are going to discuss later on. But as of now, just try to understand what they did. They did create one agent which is helping them to reduce the 21,000 plus developer hours per year. That means a lot of repetitive task is automated by their agents, right? Secondly, reduced Slack thread overload by 40%, right? New developers onboarded 2x faster. So these are the benefits which they are getting. These are the tangible outcomes which they got after implementing this entire solution. Now, I also wanted to highlight that we are very much scared, right? AI is coming in, and at the same time, what will happen to us? Will I get a job or not? So that's the reason I wanted to highlight this as well, that when they went ahead and when they implemented this entire solution, it is not impacting as such the employees' employment, right? And I just wanted to highlight that also, so that if you have any thoughts like what will happen to us, how the jobs will be, what will be the jobs. So you can see that as such, it did not impact the engineers. Engineers no longer waste time answering the same questions, increased focus on real development work and problem solving. Junior developers felt more confident due to instant AI assistance. So we have to treat the AI as a partner, right? As a helper. So here you can see that AI did not replace engineers. It became their productivity partner, right? So whatever use case they have implemented, I am going to talk about that. And at the same time, I will help you understand that how it is impacting employees positively and not negatively, right? So second use case is from JP Morgan. So investment research agent. A line graph agent that reads research papers, queries financial data, and drafts investment briefs. So here the tangible outcomes they are getting is reduced report drafting time from 3 days to 30 minutes. Analysts could research 3x more companies per day. Increased decision making speed across departments. So basically, when I want to do a report building, let's say I want to do some research. Earlier, when these type of models were not there, we had to go ahead and we have to do all those things from our side, and that will be a time consuming process. Here you can see that they have reduced from 3 days to 30 minutes, and that is like a good time saving which they are doing. Impact on employees, again positive impacts. Analysts use AI as a research assistant, not a replacement. Senior analysts now focus on strategic calls, not data collection. Junior analysts upskilled quickly using AI guided learning. Here AI took over the reading, so human could focus on the thinking. So I always tell my learners that when AI is coming in, you don't have to worry about it. Yes, you have to make sure that you are understanding the business, right? You have to expand your horizon so that you will go ahead and you can basically contribute on the functional aspects, not on the repetitive task type of aspect, right? So that is what we have to understand. Let's talk about one more use case. LinkedIn, hiring agent for talent analysis. Now, many HR, they can use AI on a positive way. So here you can see that what they built, an AI agent that screens candidates, summarizes profiles, and align them with job descriptions. The tangible outcomes they got is reduced recruiter screening time by 70%. I don't have to research, I don't have to search the types of employees which I am interested in. It's automatically taken care. Help identify passive candidates that would have been missed. Improve diversity by removing unconscious human biases, right? So that is what they are getting. An impact on the employees. Recruiters now spend more time on human conversations, not resume scanning. Talent teams feel more empowered to focus on the person, not the paperwork. Entry-level recruiters learn faster with AI suggestions and summaries. So here AI becoming a hiring co-pilot, not a hiring manager, right? So that is again benefit which HR getting in this particular application which they have built. Like this, we have another company, BlackRock, asset management agents. So what they built, reliable LangChain agents for financial data ingestion, analysis, and reporting in production environment. Tangible outcomes, automated compliances checks on investments, AI generated investment summaries for real-time feeds, enhanced client advisory speed and personalization. Impact on employees, fund managers have more accurate data at their fingertips. Analysts can focus on relationship building, not Excel cleanup. Reduced mental fatigue during peak market volatility. AI made risk analysis smarter and human insight stronger, right? So here you can see that we can see a lot of positivity coming in and it is helping us. So that's the reason this particular thing, right, which we are going to talk about in this entire curriculum, creating the agents are very important. Because now if you're getting into any company and if AI agents they have to build, then you can be one of the employee who can basically go ahead and create the agents for them. So that's why we are going to make sure that your foundations are very strong. And after completing this program, you will get that understanding and you will be very much thorough with building any type of agents in any type of domains, right? Let's talk about one more example, Cisco AI workflow orchestration across teams. So what they built, cross-functional LangGraph agents with LangSmith, observability to automate document management, support, and reporting. Here you can see that a lot of terms coming in, right? LangGraph, LangSmith, and all. So as of now, don't worry about that. We are going to discuss about that in detail. What LangChains are, what LangGraphs are, what LangSmiths are. And at the same time, we will be using LangChain quite extensively. So don't worry about these terms for now, but just try to understand what they are doing and how it is benefiting the company. So here is the tangible outcomes: cut internal documentation, search time by 50%, reduce ticket backlog in IT and HR departments, increased internal NPS, employee satisfaction score. So basically with this workflow, a lot of things improved internally for the company and how employees are getting benefited. So less time spent searching documents, more time creating value. Employees across departments use AI like a team knowledge assistant. Boosted collaboration between tech and non-tech teams. AI became the knowledge layer everyone could access, right? So basically I can ask any question in a simple English language and based on that, it is going to respond for me. And that is the benefit which Cisco is giving to their employees by creating this agent. One more example, Monday.com AI agent workforce for project automation. What they built, agents that automate project updates, task tracking, and integration across tools like Notion, Slack, and Jira. So these are some of the project management tools which they are using, and they are automating this entire thing using the AI agent. The tangible outcomes which they got is 3x faster project updates across departments, increased task completion rate by 22%, minimized communication delays in large teams. Impact on employees, that is again positive. Product managers stopped chasing updates, AI handles it. Designer/developers can focus on creative work, not admin, and remote teams stay synced without endless meetings. AI did not replace project managers, it gave them superpowers, right? So that is again one of the use cases which we have. Let's talk about one more use case, Unify AI research assistants to scale. What they build, research agents that gather information from internal sources, organize findings, and summarize key insights. Tangible outcomes, reduced time to complete a research report by 80%. Created centralized AI-powered research hubs for all departments. Enhanced decision making with structured, high-quality briefs. Again, the impact on the employees, research teams feel empowered to handle more projects in less time. Entry level researchers learn faster using AI generated guidance and improved cross team collaboration through shared AI notes. Here, AI turned scattered research into structured insight instantly. And that is the benefit which we are giving by using AI agent in the Unify, right? So these are the things which we as in the AI developers, right? They are doing in for their companies and helping the companies quite extensively. So these are some of the use cases which we have discussed, and these are already implemented, right? Like this, there are many use cases, but this is some of the use cases which I have mentioned. So AI is no longer just about answering questions. It's about solving business problems end to end. And that is what we are going to do as well while we are completing this curriculum. We are going to have a detailed understanding of all these stuffs. We are going to create a lot of agents during this entire curriculum, and we make sure how to build the agents and at the same time how to deploy the agents as well, right? So that is going to be a very powerful structured course which we are going through, and this will make us very much comfortable for developing this entire agents. So now let's get into the introduction to generative AI. Now, what is generative AI? Now, there is like a lot of misconception about generative AI. So the idea here is AI models that create new content by learning from existing data is your generative AI, right? So any model which is creating a new content, and because they have learned a lot of things in the past, because of that they are able to generate the new content, right? Because they have seen a lot of patterns, and because of those patterns they can guess that okay, this can be the next content or this can be the next sentence. So basically, when we are creating a new content, because I have learned from the past on the existing data which I have, so I have that capability to generate some new content as well. That is where the generative AI is coming in, right? Now, generative AI is not just about text. There are a lot of generative AI models. You can see here we have a language models, that is large language models like ChatGPT and all. So basically the purpose there is it generates human-like text, right? So if you see the first set of generative AI model is large language models, LLM. So that is your generate human-like text for you. Same way there are image generation models as well, right? Where create new images from the prompts. So that is also generative AI only. But here the model is generating the image. Here the model is generating the text. Here the model is generating the video, right? Here the model is generating the music and audio generation. So you can see that various different things can be generated from the past understanding. So when we are talking about generative AI, I saw that many of the people are thinking that it's about text. No, it's not about text. It's about various different things, right? It can be video generation, it can be image generation, it can be language generation, it can be music generation, it can be audio generation, text to speech conversion, speech to text conversion, code generation, document generation, multimodal, which is nothing but generating everything, right? Image, your videos, your music, your text. That is your multimodal type of generative AI models, right? So it's different types of models which we have. And obviously, we are going to focus more on the text-based model in this entire curriculum, because these models are, as of now, we are not using that extensively. But yes, in at least in our industry, we are not using that. But over the period of time, maybe we will be using image models and video models quite extensively. But as of now, the entire curriculum will be focused on the large language models only, right? Now, introduction to large language models. Now, imagine you have a super smart robot that is a friend, that is a friend who has read almost everything in the internet, books, websites, news, code, and more. Now, this robot can write essays, emails, or poems, chat like human, solve problems or explain concepts, translate languages, answer questions quickly. That robot is powered by an LLM, a large language model, right? So large language model is basically, again, one of the generative AI models. It has learned a lot of things from the internet, a lot of texts from books and websites and so on. And because it has gone through so many patterns, so now when we are asking something, it is understanding that what we are looking for, and based on whatever this machine learned, it is responding to us, right? That is what is actually happening in the large language model. So basically, this is one of the examples, a simple analogy. Think of LLM like a giant brain built by reading billions of pages. It does not think like humans, but it trained to predict the next word in a sentence, just like how you might finish the sentence. LLM do that too, just at massive scale, right? So if you see here, this is one of the examples. Vrindavan is known for. So here you can see that we have this outcome, which is a probability, right? So what machine thinks that Vrindavan is known for, 78% chances it is for devotion, 12% chances it is for spirituality, 6% chances is for peace, and 4% chances is for festivals, right? So this has the highest probability. So basically it will fill the sentence with Vrindavan is known for devotion. Now after that, again, some sentence completed now, and it is famous for. So now again, my machine will generate the probability of the words. So 82% is for Radha Krishna Bhakts, 10% is for Krishna Bhakts, 5% is for Vaishnava Bhakts, and 3% is for spiritual Bhakts. So again, the probability is Radha Krishna Bhakts. So you can see that my sentence is getting completed with Radha Krishna Bhakts. So this is how, what it does is it basically give me the input of the words, and it helps me to predict the next word. Then again, once I get the next word, I will again pass in the machine, it will generate the next word, and so on and so forth. It's like a cycle, right? So I already predicted this word, then I passed all these words, now I'm predicting the next word. So same way, when I'm saying devotion, after that what will be the next word? So end is the next word coming in. So this is again predicted by the machine only, based on the probability. This is again predicted by the machine only, based on the probability. So basically, in the first instance, let's say I gave this sentence, I got this as a response. Now in the second iteration, what will happen? This will go as a input, right? This particular sentence will go as an input, and it will predict the next word. In the next cycle, it will take this entire sentence as an input. It will predict the next outcome. Then in the next iteration, it will go and pick up till it, and it will predict the next word, and so on and so forth, right? So that is how this prediction is happening. So large language model is nothing but it has learned a lot of patterns. So it understands that what could be the next word, right? So that is what it is doing. That is the only thing which it is doing, right? But because it learned from a lot of data, it understands a lot of patterns, and because of that, the machine is generating this type of texts, and the accuracy is obviously very good, right? Now how does it learn? So it looks at tons of text and learns patterns, as I mentioned earlier as well, not by understanding like a human, but by seeing what word often comes together, right? So it does not understand the meaning, it just understands the patterns, right? There is a difference. We as a human understand what is the meaning of this sentence, but machine just understand what is the pattern of this sentence. So there's a big difference, right? So if I go back and if I read this sentence, Vrindavan is known for devotion and it's famous for Radha Krishna Bhakts. This sentence has some meaning, and the meaning I am aware of, because I am as a human understand the sentence and the meaning of it as well. But machine just understand this particular sentence as a pattern, right? As a set of numbers, because again, machine processes the numbers. So it just understand the patterns and numbers. That's it. It does not understand the meaning, right? So that is how it is. So that is very important for us to understand. So that is what I have mentioned here as well. It looks at tons of text and learns patterns, not by understanding like a human, but by seeing what words come often together, right? So that is the main idea of LLMs. Now there are different companies who are basically created the large language models. So only OpenAI is there? The answer is no. There are various other companies as well. ChatGPT is coming from OpenAI. Why we are talking about OpenAI? Because that was the first product which came in the market, right? So that's why uh, every model is now like a ChatGPT only, right? So basically, if you remember when Paytm came in, so now if I am doing a Google Pay also, they say that do Paytm, right? So basically, we are doing a Google Pay, but they say okay, do the Paytm. So it's like a, what do you say, a product which is named as ChatGPT. So any other large language model comes in, it will consider as a ChatGPT, right? Basically, we call it as a ChatGPT. Actually, it is coming from different company. So here you can see Google. Google has Gemini, Anthropic has Claude, and Facebook has Llama, right? Here ChatGPT is paid one, Gemini is paid one, Claude is paid one, Llama is free, right? So Facebook model is free of cost. So there are two types of segregation. One is the open source models and one is the closed source models, that is paid ones. So your ChatGPT, Gemini and Claude, they are paid ones, closed source models, and Llama is the open source model, which is a free of cost. Now OpenAI API get the power of this particular models in your machines, right? Now I want to use these ChatGPT type of model in my machine. So basically, if I want to do that, I need a very big machine, right? Because they have trained on huge amount of data and huge amount of parameters are there. That means your model is a very heavy model. And if I want that particular model to be part of my machine, if I try to install that or if I try to download that in my machine, it's going to be very difficult. Here you can see the comparison as well. As of now, my machine, this is my machine configuration. My machine is 32 GB RAM, 500 GB hard disk, 4 GB your GPU, one mid-tier GPU, and your one mid-tier GPU, and your cost estimate is around 1.25 lakhs. This is my machine's cost and the configuration. If I wanted my GPT-4 model in my machine, so in that case, obviously I need this much of RAM memory, this much of storage, this much of GPU, and so on. It is gonna cost me around 3.5 to 6 crore rupees, right? That means it's a huge machine. It's a big data center. And obviously it's gonna cost a lot. And I cannot do that as an individual, right? So for that, first of all, if I want this type of configuration, what all times your machine should have? So 32 GB RAM, you have to increase by 50 times your configuration, hard disk by 12 to 20 times, and so on and so forth. The cost is around 5,000 times your cost is increasing. So overall, this is going to be a bit of a challenging task for me as an individual. As a company, I can still think of, because again, let's say my company is a very big company. So I can think of having this type of big machine and I can create my own models or I can download the models from other companies. But for an individual as a developer, we cannot do that, right? We need a lot of resources and for that, we need a lot of money. So what is the solution? The solution here is that the concept of API, right? Now, API is again very powerful concept which came uh, to improve the entire, what do you say, integration of your backend with the front end. You must be using your, what do you say, apps like Zomatos and Swiggies for going ahead and ordering the food, right? So the idea is that if I try to help you understand about what API is, so when I am ordering the food and it is going to Swiggy and the guy, which is a delivery boy, comes to my home and delivers the food. So this guy is considered as an API because I am sending a request and he's processing the request through Swiggy, right? So this is like a quick overview to understand what API means. Basically a medium which is connecting the client and the server, right? In our example, let's say my laptop is a client and I want to connect to the OpenAI powerful model. So I'll connect the OpenAI powerful model from the OpenAI server. But how can I do that? Through the API. So API is basically nothing but a medium for the communication. So it came in for basically better connectivity, right? So the full form of API is application programming interface. Let's take a scenario. For example, let's say I have a flights and let's say Akasa is one of the companies which is like into the Indian Airways and Indian domestic flights, right? So basically the idea is that people are booking their tickets in Akasa Air and so on. Indigo is there, Air India is there, and a lot of other flights, other companies are there which are into domestic flights. So now the idea is basically they have their database where the entire information is present about what all flights are available, how many seats are available, and so on and so forth. Now, as of now, let's say before these companies came in like GoIbibo, Vigo, Agoda, Make My Trip, and so on. So before these companies came in, what was the scenario? The scenario was you have to go to the website of the airways itself, let's say akasair.com, and I want to go ahead and I want to book the ticket from their website. Before website was not there, obviously we had to go to the airport or some agents and we had to book the ticket. But now all www your global thing came in, right? Websites and all came in. .com burst, what you can say, it came in. So at that time all websites came in and now we are basically going ahead and trying to book the tickets from the website. So before your Go, Ibibo and other companies were not there, we had to go to Akasa and we had to book the tickets from their website and so on. Akasa was not there at that time, but let's assume that it was there. So we had to log in and we have to book the tickets. But now what happened was these companies came in and they told that we have a lot of customers coming in our websites. And if you guys can give me the access of this database somehow, we will help you to sell more tickets, right? Because a lot of customers are coming to my website and they are looking for flights. As of now, we are having a tie-up with Indigo and let's say Air India. If you guys are also looking for, you can very well come in and we will access your database and whatever the request is, if they will book the ticket, then it will be your sale, right? For every hit which I will be doing. So what Go IBO is saying is that if every hit which I will be doing to your database, I will pay you the amount. So it's a good thing, right? It's a good revenue model for Akasa as well, because how many people are going to the Akasa website? Maybe not much. Maybe they are going to some reputed airlines like Indigo. So they thought it's a good way to increase their revenue. But the problem is that first of all, the front end and the back end development which happened by Akasa, it's like very tightly coupled. That means the database which you have designed is designed for this website. If you are making any changes in this website, you have to make a change in this database as well. And same way, if you are making any changes in this database, you have to make change in this website as well. So that is how it is tightly coupled. Now, if you are saying that this website will also hit the database, that means they have to make the changes in their website as per my database requirement, or I have to make the changes as per this website requirement. And it is not feasible because tomorrow Vigo comes in, I cannot make a change out here. Tomorrow Agoda comes in, I cannot make a change out here. And same way, it is not possible for them as well because they are accessing my database, they are accessing the Indigo database as well, right? So if they are changing their front end based on Indigo, and if they want us to change, if they want to change as per our database, again, it's a problem, right? I cannot do that, all those things. It's gonna be very tough. So that is one of the problems. And because of that, these companies are facing problem because they are not getting the clients like Akasa. And Akasa is also facing a problem. They are not getting this type of marketplaces where they can sell the tickets. That is the first problem statement, right? Why API came into picture. As of now, we are discussing that what is an API and where API is coming into picture, right? So this was the first problem which was happening, that your database is tightly coupled with the front end. The second problem is when mobile apps came in, right? At that time, what companies did, they had their own websites, but after that, they created their own apps as well, right? So a website is like a web browser, you have to open that. Apps are in Android as well as iOS. Now, again, as I mentioned, that your websites are very nicely coupled with the database. So if you are making any changes on the database, your website will change. And same way, if you are changing the website, your database will change. And the problem here is that your website can be developed in various different types of programming language, right? React or your HTML or so on, right? So let's say my website is developed on HTML. Android app normally developed on your this thing, right? Java. And your Apple app is normally developed on the Swift. Okay. So all are using the different programming languages. Now, I have a one database which is very tightly coupled with HTML, the front end, the website. Now, if you want to connect this database with the Android app, a lot of changes I have to do here as well, which will impact this website. And same way, when I'm connecting with this Apple app as well, lot of changes I have to make in the database. And again, this is gonna be impacting. So basically, the idea was I cannot do like that because a lot of changes I have to take care of because all the front ends are created on different programming languages. So what is the idea is, before the concept of API, what they did, they created three separate databases. One database for the website, one database for the Android app, and one database for the Apple app. Now, for example, there is a guy. Let's say there are 10 flight tickets left. Here also 10 flight tickets left. And here also 10 flight tickets left. Now, there is a guy who booked the ticket from website. Now, here what will happen? This database will get updated. And now here we will have 9 flight tickets. But these two databases will not get updated. And because of that, there is a mismatch in the data. And we have to make sure that your database will always be in sync. So that is the additional task which we have to do. Whenever any request comes in from the website or from the Android app or from the iOS app, I have to sync the other databases as well. And that is again a problem, right? So that was the second problem which we have when the API was not there. Now, what is the solution? The solution is that the concept of API, right? So API is basically, you can say, like a code, right? It's a generic code which you are creating for this database. Basically, this code, what it will do, this code will create the records, read the records, update the records, and delete the records from the database. That capability this particular API will have. And this is known as CRUD operations, right? So now what people used to do is, and what people are doing now is, they are only developing this API, which has all the functionalities to deal with this database. Now, this front end from Akasa Air, this front end from GoIBibo, this front end from Vigo, and this front end for Agoda, I don't have to worry about that. I just have to call this API and I can very well integrate with this database, right? So API is like a medium. It's a way to connect the backend with the front end. And it is not tightly coupled. That means if you are making any changes in the database, I don't have to worry about my front ends. And if I am making any changes in the front ends, I don't have to worry about my backends. right? And that is the benefit which we are getting through API. If I come to the second problem, where we had the app, where we had the Android app, iOS app, and website, there also I don't have to worry now, because this website will be hitting the API. This will also hit the API, and this will also hit the API, and this API will hit the database, right? So the idea is that if any changes happen in the website, I don't have to worry about the database. Any changes happen in the apps, I don't have to worry about the database. And same way, if I make any changes in the database, I don't have to worry about the apps and websites, right? Because I'm hitting the API, and API will hit the database, and things are fine. So now these are not tightly coupled. These are very much independent of each other, and we are good to go, right? So that is the benefit which we are getting from the API concept. Now, as this API came in, this is actually helping a lot for the machine learning engineers, AI engineers, and now your generative AI engineers and all those things as well. Come back to OpenAI. OpenAI developed a model, right? And now I want to access the OpenAI model. How can I do that? The simple answer is go and use the API, right? So here what happens is that OpenAI created a model, and this model I want to access somehow. So what I will be doing is I will be getting the API for this OpenAI, and I will be connecting that API with my laptops, right? And now once I connected the API with the laptops, I'm good to go. Whenever I do any request, whenever I give any request, it will hit the API and hit the model, and model will respond back. So the same concept is what happening in the models as well. If you are creating any machine learning model, for example, let's say I as an HR created a model which is helping me to predict the salary of an employee. Now I want this model to be integrated with, let's say, some website. So what I can do is I can create the API of the model, and then I can give that API link to the website, and website can connect to that API link, and it will use the model which I have developed, right? So that is the power of API what we get, right? In this curriculum, we are going to see also how we can develop the APIs, because this is again one of the important aspects of this particular entire thing, right? So that's why I told you it's a very, very Python exhaustive curriculum. Here we are going to see how we can deploy the APIs, how we can create the APIs, everything we are going to discuss. We are going to discuss about the object-oriented programming language as well, which is very important for the generative AI and agentic AI point of view, right? So all those things we are going to discuss in detail. So now let's proceed further. Now, limitations of large language models. Now, what are the limitations of large language models we have? An LLM like GPT 3.5 or GPT 4 is a powerful engine trained on massive amount of data, that is books, websites, code, and so on. But here is a catch. Once training is done, the LLM does not know anything new unless you explicitly provide it in the prompt. If you remember, right, when initially this OpenAI came in, it has certain dates of learning, right? That I am trained up till this day. If a future comes in, or let's say my model is trained up till uh, December 2024. As of now, it's going July 2025. So if anything happened in, let's say, February 2025, machine will not be aware of. Let's try to understand the timeline here. My model is trained up till, let's say, December 2024, right? My model is trained up till December 2024, right? So machine is having knowledge up till this. Today is July 2025. If something happened in the February 2025, machine will not be aware of the same. Why? Because machine is having a knowledge up till that particular cutoff time, right? So here you can see that once training is done, the LLM does not know anything new unless you explicitly provide it in the prompt. It's like a genius who has read books until 2023, in our example 2024, but can't browse internet, can't query your company database, can't read PDF or fetch real-time information, can't remember what you said 5 minutes ago unless you remind it. So it's, while powerful, it's incomplete, right? So large language models has these many limitations. First of all, no latest information. Second is I cannot access internet. Third is I cannot connect to any company database. For example, let's say for my company, I want to know how many employees are there. What is the leave policy, right? What is the HR policies? I cannot answer that. Why? Because I am not aware of that. I means LLM, right? So LLM cannot answer that. Why? Because LLM is not aware of all these things. LLM cannot read any files. Can't remember what I said. As I mentioned, that it's like a limitation. The biggest limitation out here is that your LLMs are stateless. That means, suppose I am asking today, who is the Prime Minister of India? It will respond, Narendra Modi is the Prime Minister of India. Now my next question will be, what is his age? LLM will not able to answer that because LLM has no context about what was asked earlier. Although if you see in the chat GPT, as of now, it is able to respond because chat GPT is not an LLM anymore. Chat GPT is a chat model, right? There is a segregation of LLMs and chat models, which we are going to discuss in the future sessions. LLM is like old thing now, right? LLM is no longer new. Chat model is the latest thing. So basically there is a change happened. Although we are talking that, okay, we are using LLMs and all, LLM is gone, right? Now we are talking about chat models. So we'll talk about that more in detail because if you use chat GPTs and all, you can see that when we are asking any question, it responds. And if I am asking any follow-up questions, it is also responding because now chat GPT is not using 3.5 or GPT-4. It is using 4.0 and other models, right? In fact, I think GPT-4 is also chat model only, but 3.5 was not. So basically, the idea is that now the chat models coming in and chat models has certain benefits. It can remember certain context of your chat. If you are chatting with someone, like someone is chatting with your model, so it has certain idea that what's going on, right? It has certain context. I'll show you all those details in the future discussion, but yes, the idea is basically chat model is the latest state of the art skill and technology which is available and it has a bit of memory. Okay. So that is about the limitations which we have for the large language models. Second limitation is hallucinations, right? So basically, let's say if I am asking something and machine is not aware of that, so it will give me some mock-up or stuffed up information, right? And it will very much confident that it looks like very real. So you can ask something and let's say you can ask any random information and let's say that information is not present. Still your chat GPT will respond, right? And this is like hallucination which we have. So LLMs don't know, they predict. Sometimes they produce completely wrong answers confidently. Who is the CEO of your company private limited? So it will randomly give me some random name. John Fernandez, made up name. This is hallucination. Looks real, but is false, right? So this is again one of the limitations which we have with the large language models. No external knowledge, cannot browse or fetch, right? So large language models cannot search your SQL database, cannot read your PDF policy document, or browse your customer ticketing system. For example, what is the return policy mentioned in our HR manual? LLM will say, I'm not sure. Unless you paste the entire manual, it's blind, right? So that is again one of the limitations which we have with the large language models. No memory across turns, right? As I mentioned, hi, my name is Rahul. And then after that, I will ask, what is my name? So machine will not able to understand that. What is my name? In these are the limitations for the LLMs is what I'm talking about. So it's a stateless, right? LLMs don't remember your previous inputs unless you refeed them. So that is one of the limitations as well, which we have. Static knowledge, as I mentioned, that machine is trained up till 2024. Something is happening in 2025. In that case, I cannot answer that, right? Here you can see that most LLMs are trained on date up to 2025 or earlier. So if you ask for something recent, 2024 news, pricing, it may not know. What's the latest feature in LangChain is as of July 2025? No idea. Basically, if I'm asking any question, right, what is the latest feature of LangChain as on today? It will say no idea, right? So basically, LLMs are again trained up till one static date and before. So if you ask any questions for that date or before, it will able to respond. But anything happened in the future after that date, it will not able to respond. No understanding of your business logic, right? So it does not know your internal workflows, approval rules, escalation matrix, or compliance documents unless explicitly injected. How many leaves can I take as a contractor? So here it does not know, right? LLM does not know about your company, nothing. So in that case, what will happen? It will mock up the information. It will hallucinate, right? So that can happen or it will respond. I don't know. So these are some of the challenges, and this is actually restricting us to make a very powerful application. So when we are talking about agentic AI and AI agents, right? These restrictions are no longer there because there are certain tools which are available, which is taking care of these things. And that is what we are going to work on. That is what we are going to learn. And that is why AI agents are so super powerful, because all these limitations which we are discussing will no longer be there, right? Static knowledge, as we discussed already. So this is, I think, done. Give me a second. Yeah. So static knowledge is done. Next is limited format output without control. So LLMs can generate text, but if you want exact JSON, structured SQL, or API calls, it often needs engineered prompting or output parsers, right? Don't worry about these terms as of now, output parsers and all. We'll discuss that in detail. But as of now, as a layman, try to understand that when I am asking any question to LLM, it is going to generate the outcome in a text format. But suppose I want the outcome in a particular format. In that case, I have to write a prompt or I have to make a change in the prompt so that it will generate that, right? Or sometimes it may not generate in that form as well. So that is again one of the limitations which we have. Now, with all these limitations, what are the impact or what are the limitations for the business, right? So if you directly use LLMs in the enterprise or any random company, like in this particular entire series, I will be taking business process management, BPM industry, right? So if you directly use LLMs in enterprise or any BPM processes, your chatbot may hallucinate answers to employee. Your HR bot may misread leave policies. Your finance bot won't remember previous queries. Your IT resolver agent won't pull real ticket data. Your Gen AI assistant may generate incorrect summaries, and that results to poor adoption, trust issues, and compliance risks as well. Right? So if all these things are not there, the limitations which we have discussed, right? If these limitations are there with us, then these are the problems you will face. And somehow I want to take care of that so that I can use these LLMs or chat models in a very powerful way, right? And that is what we are going to discuss in this entire curriculum, how we can make a simple chat model, a agent with a lot of superpowers, right? So what do we need to take care of these problems, right? That's where LangChain, RAG, tools, and memory comes in, right? So in this curriculum, we are going to learn one framework called LangChain. So as of now, if you are not aware of that, don't worry about that. We are going to discuss this very much in detail, right? So LangChain, RAG, tools, and memory coming into picture. What is RAG? We'll discuss about in some time. But RAG is nothing but connects LLM to external knowledge, right? So I have a LLM. I want to connect with some my company's files. I can do that. What are tools? Let LLM call APIs, databases, and functions. I'll give you a simple example. Let's say I want to convert Celsius to Fahrenheit, and I want to create an agent which does that for me. But how agent will understand that when I'm asking that, okay, convert this degree to Fahrenheit, how it will understand? So I can redirect to a tool. I will say my agent that I have this type of problems. And if let's say conversion comes in, you have to hit that particular function, which is converting Celsius to Fahrenheit. So that function, which is converting the Celsius to Fahrenheit, is a tool. And that tool will be used by your large language models or chat models, right? So basically tools are nothing but some of the helper type of concept, right? If let's say I am looking for booking a flight ticket, or let's say I want to go to Shimla, right? And I want a 3 days plan that how my trip could be. So I can give LLM a prompt that I am looking for a 3 days trip in Shimla. Give me the entire itinerary, right? So what it will do, it will hit the API of the Make My Trip or Go Ibibo, get the relevant details of the hotels and all, and respond. So the API of Go Ibibo is a tool for the LLM, right? So we created a AI agent where I have mentioned that when I am asking for my holidays, you have to hit that particular tool, that is the Go Ibibo API tool, and then give me the responses, right? And now we know what API is, right? I can access Go Ibibo API and get the details. So that is nothing but tools. Same with database as well, right? Let's say I'm directly connecting to the hotel's database, right? Let's say there is a hotel in Shimla. I have access to that particular hotel's database. Now I am saying I want to go to Shimla. Give me the room costs and all those things. So it will hit the database of the hotel and give me the response. So that database is a tool for your model, right? And same way function I have discussed as well, that I want to convert Celsius to Fahrenheit. So it will convert using that function. So these are the tools which I will be providing to the agents. From where they are getting the superpowers? Because of the RAG, because it can access some external information, because of the tools which I am giving access to, because of the memory. If I'm talking about something, LLM will remember that. And when I log in next time, at that time also it will remember. And that is the benefit which you are getting. So you can see that these are the challenges which we had, and we are trying to solve these challenges. And once we solve all these challenges, automatically the agent which we are going to generate will have the superpowers. Output parsers ensure structured and safe formats, right? I can ask to generate the outcome in any random format as per my requirement. It will generate for me. And finally, agents, a smart LLM that knows what tools to use and when. When I am saying that I want to book a ticket, hit the API of Go Ibibo or hit the database of the hotel and book the room or ticket, whatever, right? And same way, if I want to convert something to something, Celsius to Fahrenheit, hit the function. So basically, it will understand automatically that yes, I want to go ahead and I want to hit that particular tool to complete this particular task. So LLM plus memory plus tool plus knowledge is your agentic AI, right? Or AI agent. There's a thin line difference between AI agent and agentic AI. So don't confuse with that. I will discuss in detail once we'll proceed further, right? But as of now, let's call it as agentic AI, because agentic AI is a bigger chunk. AI agent is just a small part, right? So let's call it as agentic AI for now. But we'll discuss about that, what agentic AI is and what AI agent is. Okay. Now, finally, what is RAG? Retrieval Augmented Generation, right? Now, RAG is Retrieval Augmented Generation. Retrieval means what? Fetching out something. I want to retrieve something. So first, fetch useful information from trusted documents like PDFs, MySQL, Notion, etc. Generation. Then let the LLM generate a natural language answer based on what it just retrieved. That means, again, as I'm discussing multiple times, that it does not have any external information. Now, let's say I am giving one PDF to my large language models. And now from that PDF, I am asking how many leaves I can take in 1 month, or let's say how many leaves I can take in an year. It's a HR PDF document which I have given to my LLM. So what it will do is it will fetch out the information from the document and generate the response, right? That is why it is known as retrieval augmented generation, right? So RAG is like saying, before answering your question, let me look it up in the right place, then I will reply. It's a combination of searching like a Google plus thinking like a ChatGPT. And you can see that if I have the Google plus ChatGPT, how powerful the system will be. Let's take an example, right? So let's say I have a lot of documents for my medical thing. And let's say I want to ask certain questions from that document. So here you can see that we have document X, document Y, Z, and so on. Now here are the questions which I am asking to my chatbot. Explain page number 22 in the document X to a layman. So what chatbot will do? It will go to document X, pick up the page number 22, and then it will give me the response in the layman terms, right? Second is generate the summary of document R in pointers. So what this model will do, it will go and hit the document R, generate the summary of the entire document R in the pointers, and it will respond. And third is give me 10 multiple choice questions from document C. So now it will go, chat model will go to the document C, see the entire content from the document C, and based on that content, it will generate the entire uh, uh, multiple choice questions. And you can see that all these are so beneficial, right? Earlier, when I used to create the tests and all for my learners, I have to research a lot. But now I can create a model and it will do the task for me. I just have to go ahead and I have to just make sure that it did not hallucinate and make sure that things are fine. And once the things are fine, I am ready with my content. And it saves a lot of time, right? Is it impacting my job? No, it is not. It is helping me to make it more efficient, right? Quality wise, giving me more powerful content. And that is the benefit which I am getting as a trainer, right? Same way you will be also getting a lot of benefits once you start using this quite extensively. So now let's try to understand this entire flow, how the things work, right? So this is the detailed architecture of a typical RAG application, retrieval augmented generation application. You will see this type of RAG everywhere. People are talking about RAG. So try to understand what this RAG all about, right? And we are going to develop all these things in this curriculum. As of now, we are just understanding the concepts, and then we'll start building this end-to-end powerful applications. So for example, this is a document. Let's say it's an HR policy document. Okay. Now I am uploading this into, here I have taken the example of S3 bucket. S3 bucket is like a storage in the Amazon Web Services. For us as a layman, understand that it's a Google Drive. Okay. Google Drive. So basically I uploaded the document in my Google Drive. Now I will be using a concept called document loader. Document loader is basically nothing but I am loading the document in my application from this drive. So here you can see that this document is now in my application. When I'm talking about an AI agent is combining this entire thing. This entire thing is becoming one AI agent, right? So when I'm developing an AI agent, that means all these steps are going to happen. And it's a RAG based AI agent. So obviously I need the document as well. So here I uploaded the document. And once I uploaded the document, what is the first task? The first task is that I will be splitting my document into multiple chunks, right? Now, why are we splitting this document into multiple chunks? The reason is that your chat models cannot remember the entire thing, right? Let's assume that this document is of 400 words, 400, sorry, pages. Now, your model is not very much in a it does not have the capability of remembering huge amount of text, right? I'll show you one thing. Just give me a second. Till this point, if you guys have any doubts, let me know. In the meantime, I'm just searching one document. Till this point, are you guys clear, all of you, what we have discussed? Okay, as of now, I'm not able to find that. But anyways, I'll talk about that first of all, and then we'll proceed. So basically, what I was saying here is that your model has no capability to store, let's say, 400 words, right? To remember 400 words or 400 pages, sorry, 400 pages, right? It has a capability of remembering only 8,000 words at a time, right? So every model has its own context window, right? I wanted to talk about the context window. How much I can remember. So as a machine, every model has one context window. Context window is basically nothing but how much I remember. I can remember only 8,000 words. Let's say in this 400 pages document, I have, let's say, maybe 1 million words. So if I directly give this entire information to your model, it will not understand it. It's very difficult for managing this. So what we do is we break this entire document into multiple splits, and all splits of around 8,000 words, right? Because it has a context window of 8,000 words. Like for example, let's say I'm using OpenAI model, and let's say it has a context window of 8,000 words. So each split will be of around 8,000 words so that it can process one split at a time. Okay. You can reduce this size also, that is up to you. But the idea is that I am breaking this entire bigger document, which has 1 million words, into a smaller chunks so that it will be easy for the machine to understand as well. Because when I am giving this entire 1 million to the machine, it will be difficult for machine to understand as well because it has a context length of 8,000 words only. It can remember 8,000 words at a time, not more than that. Again, 8,000 is just a hypothetical number. We can check it in their websites as well. What is the exact context length for each of the models, right? Every model has its own context length, but let's assume 8,000 for now. So basically, I'm breaking this entire document into multiple splits, and that is nothing but I'm splitting the document into chunks. For this, there is one tool which is known as splitter. Right? I'm splitting the document, which is again coming from the LangChain only. We'll discuss LangChain in detail. So I'm not talking about that terms as of now. But yeah, as we are splitting, so we have tools which can take care of that. You don't have to do that manually. We just have to call the function and that is it. Once that is done, I will be converting this entire chunks which we have created into numbers. Embedding is basically nothing but I am converting into numbers. Because machines can only process numbers. Machines cannot understand the text. All the mathematical calculations are happening, right? So that is the reason machine is generating the data into numbers. Once that is done, it will be storing this data into this database. These numbers which we are going to get is in the form of vectors. Vectors are nothing but a set of numbers, right? I'll show you one example in some time, but vectors is what we are storing, right? And this vector will be stored in this database. And that is why this database is also known as vector database, because it stores vectors, right? It stores vectors. That is why it has a name vector database. There are different databases are available like Pinecone, your ChromaDB. We are going to use ChromaDB quite extensively in this curriculum. Now, once everything is done here, my document loaded from the Google Drive, broken down into multiple splits, converted that to the numbers, and now it is stored in the database. That means your entire document is now present in this database in a form of a vectors, in a form of a numbers. Now what happens is that user will ask any question. Let's say it's a HR policy document. How many leaves I can take in a year, right? That is the question coming in from the user. Now what will happen is that this query which is coming by the user in the English language, first of all, that will be converted into numbers, right? So whatever input coming from the user, it will convert it into vector as well. After that, it will search that input vector in this database. It already have a lot of vectors. It is also sending one vector. It will try to find out the nearest of this with all these. I'll explain this one with one example as well. But the idea is that whatever input is coming in, it will try to find the relevant type of information from this document. And once, let's say, out of this many splits, let's say these two splits are having this type of relevant information coming from the user, these two splits will be now going inside here, plus this input is also going inside here. So now using this input by the user and these two splits which was searched at the time of semantic search, those two are also getting inside this. And the combination of user query and the searches which are coming from the vector database passed to the model. And based on the question which is coming from here and based on the relevant searches coming from here, your model will respond to the outcome. Right? Model will give the response on the outcome. And that is the entire RAG system, right? Very simple document, splitting it, converting into numbers, storing that here. User is asking any question, converted that to the number. That number is trying to match here. Relevant document coming here. Input query is also going here. Both are combined, both going together to the LLM. Based on the question, based on the responses or relevant responses, it is going to generate the final outcome for me, right? That is what happening inside the RAG system, and very, very powerful, very, very intelligent system, and very, very interesting as well. Now, what I will be going to do is I'm going to talk about the search concept, how this search is happening. That's fine that you are saying that you are converting to the numbers, search is happening and so on and so forth, but how it is actually happening. give me the idea about that. So now let's try to understand this with this example and bit of a mathematical calculations as well. Now, if you see vectors, we are defining like this, right? So we have the x-axis, we have the y-axis, and these are the vectors. It's obviously a multi-dimension vector, but for a human to understand, I am using the 2 dimensions. So here is the vector for your first disease, that is asthma. This is the vector for your second disease, that is COVID-19. And this is the vector for your third disease, that is cancer. Now, basically this document is a text, but I converted that to a number and it is stored in my vector database. And this is how the vectors are, which is shown in this black lines. Ignore this IV, right? Other lines. So this is the vector of V3, this is the vector of V2, and this is the vector of V1. That is asthma, COVID, and cancer. Now user is asking, tell me about COVID-19. So now your chatbot obviously will convert this query from the user into a vector, and then it will search in the document, right? It's a vector. It's a vector as well. It will search it in the document. And once it will search it, it will see that, okay, the input vector which I got, is very much nearer with vector V2, right? Because you are also asking about COVID and I am also talking about COVID. So this vector V2 is very nearer to the input vector. That means as you are nearer, that means you could be my relevant response from this document because you are nearer, right? Let's say this vector is not like this. This vector is somewhere like this. So in that case, this input vector will be same as V3. So it will respond for cancer. If let's say your input vector is somewhere like this, so it is very near to V1. So it will respond for asthma. But here, as of now, my input vector is very closer to your V2 vector. And because of that, it is going to respond this to my end user. COVID-19 is a contagious disease caused by coronavirus, SARS-CoV-2, primarily affecting the respiratory system. And this is how the semantic search happens. This is just an overview of this. Basically, the visual understanding. But now we'll talk about the mathematical understanding as well, how this is actually happening. So here we go. Let's take this example out here. Now here I have 3 feedbacks. I love data science, I love data analysis, and I love Java programming. Now, first of all, these sentences will be converted to numbers, right? So here you can see that I am converting it to numbers. As of now, I am using a simple way of converting the numbers. This type of concept is known as your bag of words, right? So basically what we are doing is wherever you are present, I will make it as 1. Wherever you are not present, I will make it as 0. So let's take I love data science. So I am giving it as 1. Love, I am giving it as 1 as well. Data, I am giving it as 1 as well. Science, I am giving it as 1 as well. Analysis is not there, so 0. Java is not there, so 0. Programming is also not there, so 0. That is for my first sentence. I converted that to a vector. Now the second sentence, I love data analysis. So I love data analysis. For science, Java, and programming, it is coming out to be 0. Same way for I love Java programming. So I love Java programming. All are 1s. Rest all are 0s. So basically what I did is I converted this sentence to a vector. I converted this sentence to a vector. And same way I converted this sentence to a vector as well. And you can see that all the vectors are of same length. 1, 2, 3, 4, 5, 6, 7. The length of the vector is 7. We have 7 numbers out here. We have 7 numbers out here. And we have the 7 numbers out here as well. Now, what is my interest? My interest is that I want to know out of these 3 sentences, which sentences are very much similar. If I read it in English, I can say that yes, I love data science, I love data analysis. They are of same type because both are related to data jobs. Java programming is more like a programming jobs. So I know that I love data science and I love data analysis are of same job. So they are of same type because I have knowledge, I understand the context. I as a human knows the meaning, but machine does not know that. Machine only knows the numbers. Now, how machine will decide that these two are of same type? In fact, your what do you say? Feedback 1 and feedback 2 are of same type, and feedback 3 is a bit different. How machine will decide that, right? So for that, there are certain mathematical calculations which we can do. There are different ways to do that. One is known as your Euclidean distance. Second is known as your Manhattan distance. And third is cosine similarity. For the NLP type of tasks, right? For the natural language processing type of task, cosine similarity is quite popularly used. So in this particular discussion, I will be talking about the cosine similarity only, how it works, right? So let's try to understand this. Just give me a second. Yeah. So now let's try to understand how it actually works. The formula for the cosine similarity is A dot B upon length of A into length of B, right? So let's try to understand this with these three documents, right? These three feedbacks. So let me do one thing. Let me just take this as a screenshot. Just give me a second. So I'll take this and I'll open up my whiteboard. Okay, so this is my data set. So let's do the calculation out here and let's try to understand what actually happens here. So what was the formula? The formula was A dot B upon length of A, length of B, right? If you go back to the PPT, you can see the same formula which we were discussing. A dot B upon length of A into length of B. Okay. So now let's go back and let's try to understand. First of all, what is A dot B? Suppose I have a vector A, that is A1, A2, A3, AN, right? And I have a vector B, that is B1, B2, B3, and Bn. Okay. Now what is A dot B means? That is nothing but A1 into B1 plus A2 into B2. It's like a dot product, right? So A2 into B2 plus A3 into B3 plus AN into Bn. Okay. That is my A dot B. So now let's keep that in mind. And one more thing I will quickly talk about. So we got to know about my numerator, right? A dot B means what? A1 into B1 into A2 into B2 and so on and so forth. Let's talk about this length of A and length of B. Let's say this is my vector. This is my vector A and this is my vector B. I want to find this length of A and I want to find this length of B. How will I find it? From this point to this point is my length. And what is this point? This point is nothing but origin, right? So if I want to find the length of A, what could be the formula? Let's apply the hypotenuse or Pythagoras theorem, right? This is my A, and this is what I need to find out, right? And this is my 0, comma 0. Okay, let's say this A is nothing but what do you say? Uh, let's say 3, comma 4, for example. So this is X. So this is my 3 and this is 4. This is my 4. So if this is 3 and this is 4, then what is this value? We can apply the Pythagoras theorem, right? So A, that is 3, comma 4, and this guy is 0, comma 0. So what is the formula for Pythagoras theorem, or it is also known as Euclidean distance? So the formula is Euclidean distance is nothing but square root of A, let's call it as x1 and y1 for now, right? So x1 minus x2 whole square plus y1 minus y2 whole square. Or normally you can see in the textbook x2 minus x1 whole square plus y2 minus y1 whole square, right? One and the same thing. It's because we are taking the square of it, so that's okay. Now x1 is what? 3 for me, and y1 is what? 4 for me. So this guy is 3 and this guy is 4. What about x2? Origin, right? 0. So that is 0. This is also 0. So 3 square, that is 9, plus 4 square, that is 16, square root of that, and that is nothing but 5. So my length of A will be 5 in this example. Now same I will be doing here as well, right? So I had a vector A. It has certain coordinates. I gave the coordinates as 3, comma 4. I am showing you in the 2-dimension space. Here we have 7-dimension space, right? 1, 2, 3, 4, 5, 6, 7. I'm talking about 2-dimension space. So my A is 3, comma 4. I want to find this distance. It is the origin 0, comma 0. I'm applying the Euclidean distance formula. I want this guy. So this is nothing but x2 minus x1 whole square, y2 minus y1 whole square, square root of that. That is my Pythagoras theorem. That is hypotenuse, or I can say Euclidean distance. So that is what I applied, right? 3 minus 0, 4 minus 0. So 3 minus 0, 4 minus 0, square root of that, 5 coming in. So my length of A is 5, right? Same way I will be doing for B as well. So now we got the idea how to calculate A dot B, and at the same time how to calculate length of A and length of B as well. Now let's apply this entire calculation on our this data set. Okay. So let's do that. Let's call this vector as A. Let's call this vector as B. And let's call this vector as C. Right? I want to find out which vectors are near. So what I will be doing is I will be calculating A and B, A and C, and B and C. Right? These 3 calculations we have to do. Let's do that. The best part of linear algebra is that whatever we did in the 2-dimension space, the same thing will happen in the multi-dimension space as well. So let's apply A dot B upon length of A and length of B, right? Length of A is from origin, right? So length of B is also from origin. So same thing will happen here as well. First of all, let's calculate A dot B. What is A dot B? A1 into B1 plus A2 into B2 plus A3 into B3 plus A4 into B4 plus A5 into B5 plus A6 into B6 plus A7 into B7 upon length of A. A is this, right? And what is the length? X1 minus X2. X2 is what? 0. Because I'm comparing with the origin, right? Origin is what? 0, 0, 0, 0, 0, 0, 0. All are 0. So what is the length of A? 1 minus 0 square plus 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 0 minus 0 square plus 0 minus 0 square plus 0 minus 0 square, square root of that. So my length of A will be 1 minus 0 square plus 1 minus 0 square plus 1 minus 0 square plus 1 minus 0 square. This one, right? 1 minus 0, 1 minus 0, 1 minus 0, 1 minus 0. And then 0, 0, 0, 0, 0, 0. So 0 minus 0 square plus 0 minus 0 square plus 0 minus 0 square. That is the length of A. Now same way I will be calculating the length of B as well. 1 minus 0 square, 1 minus 0 square, 1 minus 0 square, 0 minus 0 square, because I am comparing with origin, right? So this is my origin, all zeros. So 1 minus 0 square, 1 minus 0 square, 1 minus 0 square, 0 minus 0 square, 1 minus 0 square, 0 minus 0 square, 0 minus 0 square. So 1 minus 0 square, let me write it in small font. 1 minus 0 square, 1 minus 0 square, 0 minus 0 square, 1 minus 0 square. Let me put it a bit aside. 0 minus 0 square and 0 minus 0 square. 1, 2, 3, 4, 5, 6, 7. Okay. 1 minus 0 square, 1 minus 0 square, 1 minus 0 square, 0 minus 0 square, 1 minus 0 square, 0 minus 0 square, and 0 minus 0 square. That is what we did here. Now let's do the calculation. What is the numerator? 1 plus 1 plus 1 plus all zeros, because 1 into 0 is 0, 0, 0, 0. So 3 coming in. So let's put the numerator as 3. What about denominator? 1 square is 1 plus 1 plus 1 plus 1 plus zeros. That is 4, right? Square root of 4. And same way square root of 4. This also 1, 1, 1, 1. That is 2. So 3 upon 2 into 2. That is 3 by 4. That is 0.75. So I got the length. I got this cosine similarity as 0.75. Numerator upon denominator, right? Now the same thing I have to do with A and C as well and B and C as well. So let's do that. So this I did for AB. I love data science and I love data analytics. I got the cosine similarity as 0.75. Now let's do this for your AC. It's again bit of time consuming, but I just want you to understand this. Once you are aware, then you don't have to worry about it, right? So that's why I'm doing it for all the things. So A, B, and C. Let me write the origin here. 0, 0, 0, 0, 0, 0, and 0. Okay. Now I want to calculate for A and C. What is A dot C upon length of A and length of C is what I need to calculate. What is A dot C? This into C, 1 into 1, 1 into 1, plus 1 into 1, 1 into 1, plus 1 into 0, 1 into 0, plus 1 into 0, 1 into 0, plus 0 into 0, 0 into 0, plus 0 into 1, 0 into 1, plus 0 into 1, 0 into 1 upon. Let's calculate your length of A and length of C. So what is my length of A? 1 into 0, origin, right? So 1 minus 0 square plus, not 1 into 0, 1 minus 0. So 1 minus 0 square. Your 1 minus 0 square plus 1 minus 0 square plus 1 minus 0 square plus 0 minus 0, 0 minus 0, 0 minus 0. Okay. So 0 minus 0 square, 0 minus 0 square, and 0 minus 0 square. That we already aware, it's 4, right? 1 plus 1 plus 1 plus 1 is 4. So let me remove this and let me just write square root of 4 just to save some space. So this thing will become square root of 4, that is 2. So my length of A is coming out to be square root of 4. Multiply by length of C, right? 1 into 0, sorry, 1 minus 0, square root of 1 minus 0 square plus 1 minus 0 square plus 0 minus 0 plus 0 minus 0 plus 0 minus 0 plus 1 minus 0 plus 1 minus 0. That is also coming out to be 1, 2, 3, 4. So that is also coming out to be square root of 4. So that is your square root of 4. What is my numerator? 1 plus 1 and rest all are 0, right? This is 1, this is 1, 0, 0, 0, 0, 0. So 2 only coming in. So this is going to be 2 by 4. That is 0 0.5. Right? Square root of 4 is 2. So 2 by 4 is 0.5. So I got this value as well, which is coming out to be 0.5. Now let's do for BC. Right? So let's do for BC now. So this is my vector B. This is my vector C. Origin 0, 0, 0, 0, 0, 0, and 0. Right? So let's first calculate B dot C upon length of B, length of C. What is BC? 1 into 1 plus 1 into 1 plus 1 into 0 plus 0 into 0 plus 1 into 0 plus 0 into 1 plus 0 into 1. That is again 2 coming in the numerator, right? Upon 1 minus 0 square, 1 minus 0 square, 1 minus 0 square, 0 minus 0 square, 1 minus 0 square, 0 minus 0 square, 0 minus 0 square. 1, 2, 3, 4. Right? 4, square root of 4 coming in. So square root of 4 coming. Length of B and length of C already we are aware of from the previous calculations, right? So we don't have to do that again because in the above we did already. So square root of 4 and square root of 4. Right? Because we did that here already. We calculate the length of C, we calculate the length of B as well, right? We already aware of that. So let's put that quickly. So this is my number and that is also coming out to be 2 by 4. That is 0 0.5. Right? This is 1, 2, rest all are zeros. So 2 by 4 is 0.5. So now what I got? We got the cosine similarities. Right? We got the cosine similarities. Cosine similarity of A and B is 0.75, if you remember from the top. 0.75 for A and B. For A and C is 0.5 and for B and C is also 0.5. So B and C is 0.5 and A and C is also 0.5. Right? So these are the cosine similarities which we have. Now what with this what we will do? So let's try to understand this. Just give me a second. Let me open my PPT. Yeah. So what is this cosine similarity means? You did all this calculation, but what is the meaning of that? Cosine similarity is nothing but the angle between the vectors, right? You can write this particular formula as cos theta is equal to A dot B upon length of A into length of B. We calculated this and whatever number you are getting is nothing but cos theta, right? What number we got with AB? 0.75. What number we got with AC? 0.5. And what number we got with BC? 0.5. When your angle between the two vector is 0 degree, your cos theta is 1. When your angle between the two vector is 45 degree, your cos theta value is 0.707. When your angle between the two vector is 90 degree, your cos theta value is 0. And when the angle is 180 degree, your cos theta value is -1. That means, let's try to understand. This is my two-dimension space. This is one sentence vector. And this is another sentence vector. The angle between the two vector is, let's say, 90 degree. That means this sentence is very dissimilar with this sentence. There is no similarity. You are far from each other. But when the angle is made smaller, that means this vector is very closer to this vector. That means they are of similar type. The angle between the vector this and this vector is lesser, right? So now if I come back to the numbers which I have, I got 0.75. Here I got 0.5 and here I got 0.5 as well. When your cos theta value is bigger, that means your angle is smaller. And when your cos theta value is smaller, that means your angle is bigger. That means the angle of the first sentence, I love data science, and the angle between this, I love data analysis, you can see that the angle is very less. Why? Because the cosine similarity which I got was 0.75, which is much closer to 1. However, the angle between BC and at the same time AC is 0.5. That means you are more somewhere between 45 and 90. That means your F1 is almost not 90, but yes, around between 45 and 90, right? So there is a bigger angle. So the angle between these two vectors are closer. The angle between these two vectors are bigger, and the angle between these two vectors are also bigger. Now, as the angle is more, they are more dissimilar. But here, as the angles are closer, they are more closer. That means they are of same type, or they are actually of, like, semantically, they are having some sense. If you go back to the previous picture, which we have discussed on the asthma thing, you will now understand that here I was saying that B2 is more closer to input vector. That means they are of same type. And as you are asking about the COVID, it will hit this and give me the response because this is more similar to what user passed, right? So that is how we calculate this entire thing, right? And through this, we decide that which are of same type. And that is your cosine similarity. So using the RAG also you do all these things, right? Using the RAG, basically you are converting to vectors and you are comparing the vectors, and through cosine similarity, you can check it out. So where is RAG useful? We discussed about this entire concept of where can we use these RAGs, right? So everywhere LLMs need a trusted up-to-date answers, enterprise documents, legal HR finance content, avoiding hallucinations. For example, I want a HR bot answering questions from the policy document. Finance bot answering question from the Excel file. Customer support bot searching tickets database. Compliance assistant searching guidelines. If you are having a big database in your machine and you want to ask some question from the machine, from that database, the only thing which you are going to implement is RAG, Retrieval Augmented Generation, right? And that is you are using quite extensively in the industry. There are different types of RAGs which we have: simple RAG, conversational RAG, multi-document RAGs, multi-query RAGs, agentic RAG, hierarchical RAGs, and structured output RAGs. The key idea of simple RAG is basic retrieval and generation, best for FAQ bots, static document Q&A. Conversational RAG is like adds chat history, which is memory, help decks, your multi-turn agents, all those things is like conversational RAG, right? For example, let's say I have a doubt on my ticket. I will say when my laptop will come. So Amazon will reply that, okay, you purchased this yesterday, it will come in next 3 working days. Now, after 3 working days, let's say I'm asking again, what's the status? So now it is remembering the past, that this guy purchased the laptop and he asked for when it will deliver. Now he's asking it again, right? So machine is aware of that past chat, and that is nothing but your conversational RAGs. And all these things we are going to develop in Python, right? All these things we are going to implement in Python. We are going to create the chatbots. We are going to use the documents and get the responses from the documents. All those things we are going to implement practically. And you can see that how powerful this will be. And if you showcase that in your resumes, how beneficial it will be for you guys. Multi-document RAGs, retrieval across many files, sources, organization-wide knowledge bots. For example, let's say in my organization, we have a lot of documents, HR document, finance document, sales document, marketing document, and so on. So I am creating one bot, ask any random question about anything, I will respond. Whether you are asking about the HR policy, whether you are asking about the finance policy, I don't have any problem, I will respond. And we are going to generate this type of bots as well. Multi-document RAG we discussed, multi-query RAGs, multiple rephrased queries, research bots, executive assistants like that. Agentic RAG uses reasoning tools, fetch again, smart BPM workflows like HR bots, resolver will again implement all these things as well. Hierarchical RAGs navigate document structure, large technical manuals, structure output RAG, format control responses, CRM, BI integration, JSON answer bots, and so on. Basically, I want a structured format output only always. When my chatbot is responding, I want the outcome in always in a JSON format. So I can create that type of RAG applications as well, which again we are going to see in this curriculum. Now, where can we use RAG in the BPM workflows, right? Basically, if I want to implement the RAG in the business process management, where can I do that? What all use cases we have? First is HR policy QA bot. For example, your user is asking how many casual leaves am I eligible for as a contractor? RAG retrieves from HR company policy PDF. Why RAG? Because LLM alone would guess. Because LLM will not have knowledge about your company. How will it answer? So RAG fetches the actual clause from the policy and accurate information, and then it will be generated with all the compliance and all. Second use case is finance assistance for invoice rules. What is the invoice approval limit for a team lead in Pune? So RAG retrieves from finance SOPs in the SharePoint or PDF. Now, why RAG is required? Because limits many vary by region or departments. Only SOPs know that, right? So basically, I have that documentation and it will hit and give me the response. Then we have the IT help desk. Now here, what is the idea? How do I fix the VPN error 734 on Windows 11? So again, I have all the documents about the errors which people get on the Windows machine. It will hit that document and respond back, right? So why RAG here? Tech help changes rapidly. RAG ensures only current knowledge base articles are used, right? Because technology is changing quite rapidly. So there can be a chance that earlier the solution, now it is not working, some new solution is required. So I'll make sure that my documents are up to date. Machine will hit the document and give me the responses. It's again a practical use case for your IT help desk. Legal assistant bot. What does clause 5.2 say about notice period during termination? Right. So RAG retrieves the information from the employee contract or legal term and condition document. And why RAG requires? LLM cannot memorize thousands of legal variations. So retrieval ensures accuracy coming in. Right. So basically, again, everywhere you can see that I am reading the document and coming up with the responses. Travel and expense policy bot. So can I claim Ola rides between office and client site? So again, let's say there's a policy document we have, and based on the policy document, it will respond. So again, there is a certain rules and certain what do you say? let's say you are a manager, you can book a cab. If you're a just a consultant, a fresher, then in that case you may not book a cab, right? Because you are new to the company and you don't have that much benefits from the company, right? Because we are just a new joinees. So that depends on that. So we have a document. So it will hit the document and give me the response. Then we have procurement process assistant. What documents are required for vendor onboarding? RAG retrieves from SOP docs, procurement policies, Excel checklists, right? Why RAG again? Because we have to look at various documents and I have to make sure that all the documents are relevant and not outdated, and it will respond back. So these are some of the use cases where we can actually apply, right, this entire thing. And these are some of the some of the use cases from this we are going to implement as well. RFP assistant, request for proposal. Give me sample response to question on data privacy for healthcare clients. So every project has certain, what do you say, aspects which we have to take care of, and we maintain those aspects. We maintain those protocols. So while we are giving some request for proposal is nothing but something like, suppose I am working for a client and I am giving some proposal that this is what we are going to do, right? It's known as RFP. So basically we have to make some changes in their code base, or if I want some new requirement, I give this type of proposals, right? And when we have to give this, we have to see a lot of aspects, that what type of client it is, what type of security policies they follow, and all those things. So if I have that document with me, I can go ahead and I can refer that document, and based on that, it will give me the response. So this is again one of the use cases which we have. Ticket solver agent. So update me on the ticket. This is the ticket which I have raised. What actions are pending? So it will hit the database, understand about the status of the ticket, and responds back. So this is again, we are going to implement end to end, that if let's say some user raised the ticket, I want to know the status of the ticket, or if I want to close the ticket, I can ask machine to close the ticket. All those things I can do very well, and we will be implementing this again end to end, right? Customer SLA assistant. What's the expected TAT for a critical issue logged by a platinum customer, right? So again, it will check the policy document of SLAs and all, and based on that, it is going to respond that by when this particular issue will be logged. Compliance review assistant. Are we following GDPR norms for customer onboarding in EU? So every database type of problem statement, right? When we are dealing with the data and all, every country and every region has its own compliance. So if I want to check whether the implementation which I did on the coding is actually meeting the compliance or not. So what machine will do? Machine will check my code, hit the compliance and check whether the compliance which we have, which is decided by the GDPR norms, is that implemented on my code as well or not. So you can see that a lot of things are happening dynamically here, right? Using this type of RAG systems. So that is it. This is what I wanted to cover. I hope this makes sense. I gave you the brief overview about what we are going to work on and what's going on in the industry. From the next session, we are going to explicitly understand the various frameworks, and we will be picking up one of the frameworks and we'll start understanding that framework end to end, right? So that is the idea which we have. Now here is the quiz time. Let's quickly go through the quiz and let's see what is the responses. What is the primary function of generative AI? Store large amount of data, predict the weather using historical data, create new content by learning from existing data, perform basic arithmetic operations. So here the correct answer is option number C. So here you can see the correct answer is option number C, because generative AI creates new content, text, images, code, etc. by learning patterns from existing datasets. Which of the following is correct example of large language models? MySQL, ChatGPT, Excel, or Oracle? So the correct answer is ChatGPT. ChatGPT, developed by OpenAI, is a large language model designed to understand and generate human-like text. What is the core technique LLMs use to predict language? Rule-based logic, neural network pruning, pattern recognition from large text datasets, data compression. The correct answer is option number C, that is pattern recognition from large text datasets. LLMs are trained on large volumes of text data to recognize patterns and predict the next word. Which one of these models is developed by Google? Claude, Gemini, Llama, or GPT-4? The correct answer is Gemini, right? What does the OpenAI API allow developer to do? Build websites, access and use OpenAI models in their own apps, train their own LLM from scratch, store PDFs in the cloud. The option is option number B. Access and use OpenAI's models in their own apps. OpenAI API allows developers to integrate models like GPT-4 into their own applications for NLP tasks. What is the key limitations of large language models discussed in this particular discussion? Too much memory usage, cannot generate images, no access to external or real-time information, cannot generate text at all. The correct answer is option number C. LLMs cannot browse the internet or access private databases unless explicitly given the data. That is RAG. What is hallucination in the context of LLMs? Visual content generation, producing text in different languages, confidently generating incorrect or made up information, memorizing the user's input permanently. The correct answer is option number C. Hallucination refers to the LLM making up facts or data that seems plausible but are false. What technique connects LLMs to external documents or database? Hyperlinking, LangChain memory, Retrieval-Augmented Generation, RAG, or JSON formatting? The correct answer is here, RAG. RAG is a technique where external knowledge is retrieved and fed into LLM to enhance responses. Why do we need tools like LangChain in enterprise environments? To make the interface look better, to fix bugs in Python code, to enable memory, tool usage, and document retrieval in AI workflows, to convert images into videos. The correct answer is option number C. LangChain connects LLMs to tools, databases, and memory modules, making them more useful in business workflows. And the last is, which of the following is not a limitation of large language models? Static knowledge cutoff, no memory between turns, understanding complex emotions, inability to access structure external tools. The correct answer is option number C, understanding complex emotions. LLMs can simulate emotional understanding to some extent. The actual limitation are around memory, knowledge, and external integrations, right? So I hope this session makes sense. You got a good understanding of what LLMs are, what generative AI is, what's going on in the industry, what all companies are doing this, and what all companies are already implemented interesting solutions, and what are RAGs. A lot of things we have discussed in this entire curriculum, in entire basically discussion. Talked about cosine similarity, how we can check the similarity, how the RAG system works, what is a splitter, what is the embedding, what is a vector database. So a lot of things which we have discussed. So I hope it makes sense. We are going to connect again next week, and there we are going to discuss about the interesting tool called LangChain. So we are going to use this LangChain for creating the entire nice RAG systems and powerful agents. But before that, we are going to understand LangChain in detail, theoretically, with various examples practically as well. And then we'll start creating the entire end-to-end agents. All right, so thanks for your time. I hope you enjoyed the session. Any doubts you have, let me know.